just to start, say I'm in general a .NET Foundation member and an European member of the Digital Alliance. And that means that the Community European focused on the focus group on artificial intelligence. I'm a Techstars mentor and a Scrum Master, a data scientist, and I founded the Turing.NET Meetup. So my life started with the .NET framework. And what we have to see, we moved to also use Python, Java, and Golang. And today I will present you how we use gRPC in an unconventional way. Just in Ghostwriter AI, that is a product of my company, You Are My Guide, we use advanced natural language processing algorithms. And these algorithms are used to understand text and now images, just to understand what people are talking about, just when the contact on the CRM, on the social networks, on the calls with the company. So the contact point is the touch point. So if we are happy, if they are not happy, if they want some assistance, if they need to buy something, and all of this to create advertising and hints to support the marketing process. So the idea is to collect data, to analyze this data, and to provide hints and suggestions. Just to arrive in the last year to automatically create text, and automatically create advertising. So, but something that now looks quite good, but not so crazy. It was crazy when Ghostwriter AI and You Are My Guide was created and the idea was born. Just imagine, we are talking about 9 years ago. So there is a very long time. And the first project that used the Ghostwriter AI algorithm was called Yangu. And the Yangu was a preview of Google Trips just to create personalized routing. So if I said I want to visit Rome, the ghostwriter just scraping what is going on in Rome, on the events, on the museum, on tickets, and knowing my preferences. So just put my preferences and the preferences of my friends, just create a real-time guide with the text, with open hour to tickets buy. So we are talking something 90 years ago. 90 years ago, what it means in really old age of technology. That means that there is no TensorFlow and no PyTorch. There is no labeling support services. So if we want to create a data set, we have to collect the data sets. If we need data, we have to create data. If we want to clusterize something, we need to create by ourselves a system to clusterize data analysis. There isn't a lot of machine learning, artificial intelligence services as we know today. Just think today, Google Cloud, AWS, Microsoft Azure, there's a lot of services. 9 years ago, there's nothing about machine learning. The services that just started just as a beta product were in the US. And what we worked also with financial compartment and bank department, natural security services. So it is not possible to move this data outside of Europe, for example. There is no GPU support of a lot of services, and there is a lot of this support in the cloud. So it was a different world with respect to what we now know about the Azure in general, AWS, and cloud services. We started the service using C# because it was the framework that we know on Windows. And in a few years, we moved to the machine learning area on Python. And just we start to have the first problem to create a microservices. Because C# was where our API was written, and was all the other frameworks that we use was written. But to use Python to have the machine learning services, and just to have to put them to communicate using REST API at the beginning. Just the microservices use a simple RabbitMQ, so a simple queue to have the task. And the REST API was the core of all the communication. So there was all the inside machine learning system communicates itself. All they communicate through the REST API and the high-level APIs that aggregate machine learning algorithms inside our platforms, and was just the integration with the other services where our customers are also REST API. So just it's not real architecture, but just is an abstraction, very simple. Just imagine that the laptop is our customers, that we know who the customer is, like when you create on Google Cloud the tokens, but we know the APIs, we know everything about these customers. And these customers arrived, and just to have the access to the public service, just to have authentication, authorization, first thing, so load balancing, the REST API itself, and application file just to understand how to mix this information and just to authorize some kinds of operation. There is an high-level services. This high-level service can communicate itself and just use the low-level machine learning exposed models just to collect the data, have the information, and aggregate a response. So it means that a single call that arrive from the laptop is completely different than something that arrive at the end of the flow. And is not a one-to-one, but just the high-level service can aggregate a lot of other services. In the beginning, a lot of restriction arrives, and we have to get there and just transform there in opportunities. We have something about the GDPR, as you know, but also we have this contract that was not possible, for example, to sharing data. Also, the algorithm of ghostwriter AI goes up, and some customers decide, okay, I want your algorithm, but I don't want to use not our cloud in general. We cannot move our data outside. So we wanted you just release and deploy a lot of this kind of little services, to have a mashup of them on premises on our cloud or on device for something that is completely not connected to internet. And we also can work inside a specific machine. So just we say we cannot go out to Europe, and for bank, we cannot leave the country. And this data center, there's a lot of problem. We don't have access. We don't have internet. We have no CPU. And sometimes we have a lot of other contract and legal restrictions. So we have to manage something that is to be fast, that they have to work, but we cannot manage it in any way. And a lot of our customers have no idea how to manage it. And you can imagine a lot of data that are incoming are a lot of microtasks. So there is a very big task of, okay, I have to clusterize the machine learning system to learn to create the models. But there is no way to say if we income a lot of microdata like tweets. So it's quite strange. And our first customer asked us to say, okay, I want to use Golang, because internally in our data center, we have Golang. And asked us to create, for example, SDK. So I want an SDK to do all the calls in Golang, because I see your REST API, but your REST API are a lot of calls, and it's very complicated because they have to mix them together. And sometimes it is take a lot of time to respond because I ask something very complicated. Okay. So we started to do everything on Golang, and our second customers ask, okay, I want the same for Java. So just we start to create SDK, but it's a lot of work, so we are only five of us at a time. And in the meantime, so you know, there is all the problem that we have, and without seeing them. So inside the data center of customers, they start to have lack of data. They start to have a problem of network. They start to have all the problems that we know that exist on the microservices. In the beginning, our first customers, there was the big customers that we have at the time, the messages incoming on the platform rise to 88 times the original numbers. So they moved from 60,000 messages to 200,000 messages, but the first 60,000 for the 220,000 for each hour. So the problems that we solve just scaling or put more machine just become too costly. So it wasn't really impossible to manage this, only put more servers. And on the other end, because all of them is from socials, or is from interactions like advertising or mobile purchase, there is not constant. So we have hours with nothing happens, and there is other hours when a lot of millions of messages arrive to the platform. So we start to collect also metrics, just to say, okay, we cannot resolve this without seeing what is happening inside your data center, inside your containers. We need a lot of metrics. So we just collected the metrics, and we see that CPU and RAM is not the problem inside this data center. The memory in general, there's a lot of memory from the data center just to do machine learning analysis. But the 90% of resources are in the machine learning AI area. So, okay, this is an area that is not possible to optimize. It was just optimized. But there is a 10% that is from the arrival of the first calls at the end to arrive in the machine learning area and come back on the response that is possible. We thought that it was possible to be optimized. And just to imagine 200,000 calls every hour, the 10% optimization is not, are not few data. The first one, okay, so okay, we have to optimize the data center area. If I optimize the data center area and I optimize the machine learning algorithm, we can do something. We can remove some API services. It's okay. What I removed, I removed. So if you go to our slide, we can see that the high-level services, we include the Onyx and machine learning AI. So we don't have a services high level that calls a machine learning exposed models, but these models is included in the high-level services. But it's not possible also if this model to be shared, we have some kind of other problems, because we have to put this inside every applications, and we have 400 instances. So it wasn't the solution. Getting more metrics, we see that the problem is on the serialization, deserialization, communication, dedication. So all the problems of the metrics analyzed is in this area. So just we start, okay. If we use the protocol buffer, just the standard of gRPC, we can have a way just to generate some kind of SDK. So we don't have to create something just from scratch from other languages. But if we use just the protocol buffers just from the high level, we can also put them inside in other languages. So we are created for Java, we are created for Ruby, we are created just for Rust, and this is not so totally compliant, and so on. It's just, okay, one problem is resolved. The SDK is easier to be created. We started our service definitions. So we create all the services and the RPC on the messages. So we started to move from the REST calls inside our system to move to gRPC. The second problem that we have was the problem of the load balancer. We moved on the load balancer directly on the client of gRPC, and it was easier also to manage or to reach the other system. So just imagine there's something at the moment that everything is written inside of the balancer to do REST API calls. Our customer, obviously, and we have some networks, as you can imagine, with COBOL and so on, that ask, okay, but we don't have the firewall authorization, the people to immediately switch some of our services on to call gRPC, not just on cloud, but just internally on device. So we use also KrakenD just to say, okay, we can create a gateway for gRPC. So Our customer just can continue to use REST API. We can just move to gRPC. Internally, our system is moving to gRPC. The authentication that we have on the high-level system, the recent authentication on the model system at the time, was completely reviewed to be used the authentication inside with certificate. Now we can see just the few calls from the guide just to have the C# calls to create a channel with SSL, and the same with Python. So say, okay, with gRPC just have built inside something to authenticate people. We just can use this. So it's not a way to create automatically a token, just what you do on cloud platform, but too simple. We do the same to generate certificates. Also for the customer that want to call us outside. So in the green, you can see what is changed just okay to work better using gRPC, automatically gRPC, what is inside the possibilities. Just doing this little trick. From the final user API, so the average of the call that starts from the laptop arrives directly, for example, to the core high-level services and come back using lots of machine learning. Just what we have that we save 4 milliseconds. 4 milliseconds, that's something that seems not so much. But for 200,000 calls per hour, just it means that we save 13 minutes per hour. So just saying, we are rewriting something in gRPC, okay, we gained 20% or 20% of data just on the channel of movement of the data inside the platform. We were new for us gRPC. We don't know so much gRPC, so we configured all the services using Unary and using some channel spots, but just to start, to have a look. When we go to gRPC, there is something that happens. When we are using REST API, we are just doing a call and have a response. We don't manage too much about latency and output because there is not something that we were looking for. So, okay, there is the REST API, this is the answer. In gRPC, we have the possibility just to move something and just to say, okay, what we have to change because we need one and not the other. And this is interesting because if we have 108 projects, from these 108 projects, a lot of these projects is completely different by others. Just have a look. If we receive a text we have to call machine learning model to be aggregate data to create sentiment analysis, hashtags, entity recognition, links, and so on with thousands of data. The image is different. I want a semantic classification, so I want to know that this is inside, there is a kids, there is a car, there is a night, this is in the city. The colors are opaque, are vivid, and so on. There is my brand inside. So this kind of operation are different kind of computation. And also, if you imagine you have to analyze a tweet or a spot because I want to analyze it or to predict what is working a new advertising on Facebook, for example. I need on my call, on my analysis, all of them for the text will be completed until I have a response. So it doesn't matter if the sentiment analysis is very fast, if the job act is very slow, because I need all of them to have a response. The image is completely different because just also the transmission and the channel of all the bytes of an image is very different to move something like a tweet. When we started to deploy this solution to other customers, also we see that obviously the data center is not the same. The computation possibilities are not the same. And also how they use our system is different. So if they analyze video or analyze tweets, It's completely different. So our concept of latency of throughput had to be configured for 108 projects in different way, and they also can change customers to customers. But obviously, a lot of our customers have no idea of their customers use their platform to collect the data. Because just they simply don't know. They have never traced just to understand in for many countries or the times when something happens. So just when we have to resolve this issue, we say, okay, we have resolved an issue because we are using less computation resources because we switch to gRPC. But we can have no idea, or we can scale something that is unpredictable. Okay, we are use Kubernetes, we use Docker Swarm, we use a lot of other systems. But the only way to scale is to put more machines. Now, if the machines is limited, here there isn't business. Just to say, if I have a lot of images, but I need to solve the entity recognition on text to response, this isn't true that is, okay, I just scale something. I have to scale something to be sure that a single response arrives on time. So it's a little different. So we don't know the number of messages that could arrive. What types? This is a tweet, an images, an article, a video. We don't know when these messages arrives, the length and the size. So is an article, is a tweet, is a video. The network state itself, we don't know, because the network state depends on the data center of the customers and the load of other machine of the customers. So I will start, okay, but we are a company that use machine learning. And in the past, we used a custom protocol just to simulate something that TensorFlow and PyTorch now is natural for them to do. Now we know how to trace the latency of the output. We are the admin of the container, so we create the application inside the Docker of the customer. We cannot access them what we created, but we don't know the load. Okay, if we are able to collect this data, we can use another system of machine learning just to put them inside a recommendation system for the possibilities to create customized gRPC configuration. Just if we return of the architecture, imagine that a lot of things arrive to REST API. If I have a lot of calls to REST API, it's okay. But we can switch to gRPC. If we move to gRPC and the high-level service, the high-level service, they know how many data, how many messages, the size and the latency messages to call the machine learning models that also are exposed on Python at the moment. So what do? We put all inside a machine learning system, and just to have the metrics as response from the models. Just what it means? What it means that we are able to change all the old system is exposing or is calling is channel, so the clients and the server on gRPC, and the system close one of this channel, reopen the connection using a completely different way. So they can change the number of channels to use. They can use if this is one single call in unary, is different, have to happen on a stream, and both of them have to open and closed. Also, when the load of the system change, predictable, when we suspect that something happens. So studying the data that are arriving inside the system, because we know that every Sunday morning, for example, our customers receive a lot of interaction, we can just move on this way. So we left the machine learning system to automatically decide how to create the connection. Obviously, we can adjust the configuration to the business purpose. So we can say, okay, if I can collect the data about some kinds of services to say that altogether I have to respond fast, it's better to share and just provide more services or to change the way these services are exposed, respect to have more machine to a service that is okay, it's not fast, but it doesn't matter because you have also to expect just to wait the other system that is not possible to have more response. Obviously, easy on the slides. The difficult part was that we have more complexity, absolutely. We know that the operating system difference works in different way. Just for example, we have customers that deploy something directly on Metal, so not clouds, non Docker or Kubernetes that are using, for example, Windows. We have to consider the switch time. So, okay, I can be more fast, but just the time to restart a service with another configuration takes time. There is problem about the program languages policies. For example, if you see in the optimization system, the Python, if you use the stream connection is not so good on Python, so you don't gain the same performance, for example, if you switch on C# or on Go. There is the downtime message policy, so if the system goes down because you are restarting too much machines, just have to understand if your message is lost or is in the queue. You have the default just to start, and the possibility to also the customer to stop something to say, okay, you don't have to get more machines, or just to create more channels because you are saturating the network connection, or your machine are taking all the bandwidth that we have. The impact of just leave the gRPC machine learning to optimize by itself the gRPC connection just was again of 0.003 seconds. That again, there is 10 minutes left per hour. So we gain 15 minutes switching from REST API to gRPC, and without knowing nothing about how to do the optimization, because we have to configure 108 projects, we set just the machine to say, okay, optimize by itself. I just have just a language, just a description to say this is important, this is connected, this is not important. You don't have to use too much resources like CPU, RAM, networks, and just optimize itself and just predict. Because you started from 2 months, 3 months, you just to start to understand that it works the consumers expectation. So the big picture, just to leave gRPC to optimize by itself, is save us 23 minutes per hour in total. In general, every day, just we start to save 8 hours, 9 hours per day. So what we do is just switch to gRPC and just say, okay, manage by itself what is important for you. We can adjust to have some limits. And to sum up, just to what happens on our cloud software, you can see, just we have what is the most used configuration from our customer and our system. So the stream is most used just for analyze long text, obviously for images. Stream is never used on .NET Core Windows. So the test, the machine learning algorithm tested it must just continue to use Unary. Unary is always used in Python just for the problem said about the streaming. The bidirectionally less than 5 minutes, and the channels pulse just to 5 to 188, and mean is 28 in general. So now we have the possibility to do the things in another way. So something that is very important, also is very constant, we are dismissing the optimization or just to use this algorithm. So if we say that in 1 month, 2 months is obviously constant, now automatically we know this is the best configuration for the customers. So we put something to say, okay, don't try to optimize it every 1 hour, but just you can check if it's going to work in the same way 1 in a week, and so on. So we optimize the gRPC optimization as just because we are lazy and because we don't know how to optimize and because our customers change without the possibility to access. Just to say on the last one, in this project, we are working to just to say and just to release on open source. And so just to have the other posts just asked by myself, just if you think this is interesting to have it on open source, just you can use it or no. And I thank you for having me. If you have any question, please don't be shy. I'm here for you.